Let us look at this game. There are two players, player 1 and player 2. Player 1 has two strategies X and Y. Player 2 has two strategies A and B. Can we find out pure strategy Nash equilibrium in this game? When player 1 plays X, then player 2 has two choices, either to play A or B. When he plays A, he gets 2. When he plays B, he gets 0. So of course he'll go with A. So when player 1 plays X, player 2 plays A. When player 1 plays Y, then player 2 again has two choices, 0, 5. So he will go with 5. That is, player 2 will pick up B. So there is no consistency here. Similarly, you can also look for player 1's choices when player 2 has made a decision. So for example, if player 2 plays A, then player 1 has two choices, either to play X or to play Y. So he will definitely go along with X. Similarly, when player 2 plays B, then player 1 has two choices, either to play X or to play Y, so he'll go with Y. So there is no consistency. So in this case, there is no pure strategy Nash equilibrium. Can we find out a mixed strategy Nash equilibria? Maybe. So supposedly player 2 plays A with probability Q and plays B with probability 1 minus Q. Player 1 plays X with probability P and player 1 plays Y with probability 1 minus P. Though I'll repeat it, I've already talked about this in our earlier recording on mixed strategy Nash equilibrium, but in order to drill this fact in your head, I'm going to repeat this again. When player 1 plays X, his payoff could be either 5 or 0. But whether it would be 5 or 0, it is dependent upon whether player 2 is playing A or B. Only when player 2 plays A, his payoff is 5. When player 2 plays B, his payoff is 0. Similarly, when player 1 plays Y, whether his payoff is going to be either 0 or 2 is dependent upon whether player 2 is playing A or B. Similarly, if player 2 plays A, whether his payoff is going to be 2 or 0 is dependent upon player 1 playing X or Y. You getting the point? So, you will find out the expected payoff from playing X, expected payoff from playing Y, and he will mix these two strategies if EX is equal to EY. Now, this is going to be the function of whether player 2 plays A or B with probabilities Q and 1 minus Q. With probabilities Q and 1 minus Q. Okay, now let's see this. So player 1, the expected payoff from playing X, he can get either 5 or 0. He can get either 5 or 0. He will get 5 when player 2 plays A with probability Q. He will get 0 when player 2 plays B with probability 1 minus Q. Okay, and this is what you have written out here. Now, what is the expected payoff from Y? Expected payoff from Y is either 0 or 2. Sorry, you have to find that out. From playing Y, he can get either 0 or 2. Expected payoff would be this, 0 into the probability Q, because it is dependent upon whether player 2 is going to play A with probability Q. And he will get 2 if player 2 plays B with probability 1 minus Q. And this is what you have written out here. And he will be indifferent. He will mix these two strategies if EX is equal to EY, and you just put this equal, and you got Q equals to 2 by 7 and 1 minus Q as 5 by 7. Similarly for player 2. Player 2 has two strategies A and B. Expected payoff from A, he will have either 2 or 0. His payoff will be 2 if player 1 plays X with probability P. His payoff will be 0 if player 1 plays Y with probability 1 minus P. And this is what you have written out here. Similarly, player 2 is going the expected payoff from B. So he can have either 0 or 5. He will have 0 when player 1 plays X with probability P. He will have 5 when player 1 plays Y with probability 1 minus P. And this is what you have written out here. Now he will mix these two strategies if EA equals to EB, and he will put 2P equals to 5 into 1 minus P, and P is equal to 5 by 7, and 1 minus P is equal to 2 by 7. So the mixed strategy Nash equilibria of this game is that player 1 is going to play X with probability 5 by 7, and he's going to play Y with probability 2 by 7. Player 2 is going to play Q with probability 2 by 7, and player 2 is going to play B with probability 5 by 7. Okay, and this is what you have written out here, which is this, that is player 1 will play X with probability 5 by 7 and Y with probability 2 by 7. Player 2 will play A with probability 2 by 7 and B with probability 5 by 7. In the next video, we'll talk about the mixed strategy Nash equilibrium payoffs of this game.